Hi again, everybody. This is Professor H. I am here to talk to you tonight about Chapter 1, Section 3. We're going to talk a little bit about experimental method and the research methods used in developmental psychology. So let's go ahead and get started. I'm going to do a screen share here. We'll get right to our PowerPoint. Hopefully you're seeing this PowerPoint now. And I'm going to go ahead and click on slideshow and we'll get started. No, that's comments. Where's slideshow? Okay, there it is. Okay, Chapter 1, Part 3, How We Study Human Development. We're going to focus on the scientific method, research measurement, designs, and ethics. My degree is in experimental psychology. I happen to love research methods, anything with the science behind all of it. I'm going to try not to geek out too hard on you. I'm going to try to keep this short. I have a risk of getting very long-winded with this because I get very excited about research methods. Okay, that being said, let's move forward. So, do you remember back to middle school when you started to do your science project? Hopefully you did those and not just your parents, but usually your parents would help you like the day before it's due to get you your things together and do a science experiment for the science fair. The scientific method that you learned in middle school doing the science fair, those are the same 5 steps of the scientific method that are used in science in real life. We're going to start talking about these basic 5 steps. First thing you're going to do is you're going to identify your question, the research question that you want to ask. You're going to form a hypothesis, which is asking your question in a specific way, which we're going to talk to when we get to that. You're going to choose a research method or design that fits and can answer the question that you're asking. You're going to collect data. You're going to evaluate that data and draw conclusions. Okay, so the scientific process is kind of a circular process. You're going to start off by identifying a research question right up here. It may begin with previous research or theory or the researcher's own experiences. So oftentimes a researcher might be reading other literature and say, oh my goodness, I wonder if they would have looked at this problem this specific way, maybe they would have gotten a different outcome or could have found some more answers to the questions this way. Or maybe an experimenter is doing their own research and something pops into their mind like, oh, maybe we should try something else. So that is how you're going to come up with your identify your research question. Once you identify your research question, you need to propose a hypothesis. A hypothesis is one possible answer to the main research question. So the hypothesis is stating your research question in such a way that you can either support it or basically disprove it. So, for example, you might say, teenage boys suffer more depression than teenage girls. That would be a hypothesis, and you would be saying a direction. In other words, you think that one group is going to show more depression than the other group. You're basically going to predict how it turns out. And that's your hypothesis. You're going to choose a research method or design that is appropriate for the question that you are asking. Research methods include questionnaires, interviews. Research designs may involve one point in time or many points in time. Those are just kind of a brief feel for different methods. There's a lot of different methods that you can use. Once you settle in on a method that is going to adequately answer your research question and your hypothesis, you conduct the research. After you conduct the research, you collect that data. You then evaluate that data And after you evaluate that data, you draw conclusions based on the data. Data are analyzed and published, leading to a new hypothesis and the development of theories. So once you analyze the data and the specific statistics you're going to use, all of that kind of stuff is determined ahead of time when you're doing your research methods for the most part. And say you come up with a answer that's very different. Say we're talking about, oh, teenage boys suffer from more depression than teenage girls. And that is the kind of standardized, and this is not a real thing, but say that this is the standard research of the day, and your research comes out the opposite, saying that teenage girls are suffering from more depression than teenage boys. So you're finding out something different. So at that point, you're going to take a look at other literature, see if there's other literature that supports the same findings that you had. You're going to look at your methods, see if they turned out, if you were doing things the same way that it was done in previous studies. Maybe you're looking at a different population. Maybe it was a different socioeconomic status that you're looking at than all the previous literature had. I mean, you're going to take a look and see what differences there are. After you do all of that, you may come up with a new research question. Or maybe theories that are in place may have to be modified based on a number of findings that support your finding. Anyway, sorry, I get a little wordy on these things. So it's circular. So you identify a new question, propose a hypothesis, choose your method, collect data, draw conclusions, and once again, it starts again. Okay, so another look at these 5 steps. Identify a question of scientific interest. It can come from previous research, a theory, or personal observation. Step 2, form a hypothesis. Researchers' ideas about a possible answer to a research question. It will dictate research methods, design, and analysis. In other words, the question you're asking is going to determine what methods you use to answer those questions, because depending on the type of research, you can only do certain things. For example, if I wanted to find out how, like some other research I did before, how amphetamine affects certain brain areas in the early postnatal period, I may be able to do that using rats, an animal model, and then be able to look at the tissue from the brains of those animals. Well, I can't do that in a human being. So that would make a difference in the type of methods. With human research, obviously you cannot do some of the same things you can do with other types of research. Okay. Step 3, choose research, measurement, design. The way that the hypotheses are investigated. So depending on what question you're asking, you need to determine that question is going to determine the methods that you use. If I need to find out a question that I need to ask a whole lot of people, and I may have to do some type of survey research instead of some type of some type of experimental research. So there are different types of research that we can do, a whole lot of different things. Number 4, collect data to test the hypotheses. Researchers try to collect a sample that represents that population. And what this means, okay, researchers try to collect a sample that represents the population. So if I want to collect data regarding gun legislation, and I want to say, okay, I want to know if college students support gun control measures, or if they support maybe looser gun laws. If I wanted to find out, oh gee, I want to know, I'm going to hypothesize that college students want tighter, stricter gun control. And I go to a group of students, and say I go to the liberal students against guns or something, their club or their group. In that case, that I can pretty much be guaranteed that that group is going to give me the type of data that is going to support my hypothesis that says that this that all college students are going to say that we should have stricter gun laws. However, that's not a representative sample. In order to have a representative sample that represents the population, I would need to have that club, several other clubs, random students across the board from pretty much every discipline and every area. Maybe I would have to go with the Republican kids and the Democrat kids, and I would have to collect data from all of them before I could, and from several different college campuses, before I could answer that question. Because just the one small group is going to give me a biased answer. It is not going to be a representative sample. Just like if I questioned an NRA club kids, they are going to give me a different answer. So what I would need to do if I'm looking at all college kids within the community college district, I would have to ask a broad variety of community college students across a broad range of areas. Okay, it's late. Okay, and so step 5, draw conclusions and form new questions and hypotheses. When you analyze your data and interpret it, you will also be wanting to look at other peer-reviewed data. So when it's talking about peer-reviewed here, so say I analyze my data, I'm interpreting it a certain way, and I want to publish my data. So I want to publish, say I want to publish my data in the journal Science, okay? So I want to do that. So what I have to do is I have to take my research project, I have to submit it to the journal that I want to submit to. Let's just say we're submitting it to the journal Nature, because they're pretty awesome. So we're going to submit it, and then what's going to happen is that journal is going to select a certain number of reviewers to look at my research. They're going to look at my paper, they're going to evaluate the methods that I used, they're going to make sure that I have conducted my research in the best possible way. They are going to do this in an anonymous way. So the people who are reviewing my research paper, they are not going to know that I wrote that paper, and I am not going to know who is reviewing my paper. So pretend they looked at my paper and they're like, you know what, this is pretty good, but we think that there's a little hole and you need to test for this one other thing before we feel that your paper is ready for publication and that this study is complete and ready for publication. So I may have to go back to my lab, run a few more experiments, and then analyze my data, go through the scientific process, analyze my data, submit it, rewrite it, send it back to the journal. And then when those experts review it, and now they say, yes, now we feel like your research is valid, and we feel that it is worthy of being published in this journal. And that would be a panel made from my own peers within that specific specialty that are going to review my research. So they would be the experts in the field that would know the best about my research, and then we would be able to go ahead from there. That's what it means to have peer-reviewed articles, peer-reviewed research. That's really important, because all through your college career, if you're going to continue on, when you do research papers, you're going to need to find peer-reviewed journal articles. And that is what peer-reviewed means. So hopefully I've cleared that up to you and made you understand why it is so important. Okay, so your data, after you make conclusions from your data, it can lead to theory modification or changes. So I kind of alluded to that already. If you find something a little bit different than what has happened before, and several other people do that same type of study and all come up with the same thing, it's replicated. In other words, this research can be repeated and is not just a one-time fluke, then it's possible that we may need to modify an existing theory. That's why science is always changing. In science, you don't prove anything, but you have an ability to disprove things and to support ideas. All right, we're going to talk a little bit now about how we collect our research data. How do we conduct our research? There are a lot of different ways we can do it. First, we can talk about questionnaires. Those are closed-ended or open-ended quantitative data. Questionnaires can be very handy. If you want to ask a whole lot of people questions, you want to talk to everybody in your psychology department, you want to talk to any freshman who's willing to answer your questionnaire, that would be very expensive to do if you had to do one-on-one interviews with this person or run them through a lab. If you do a questionnaire, you can gather a lot of data very quickly. Kind of the downside about questionnaires is not everybody always answers questionnaires honestly. I'm sure that many of you have gotten a little questionnaire from somewhere on your phone, and you've answered the little questionnaire and maybe not felt comfortable answering honestly on some of the questions. And that is the way that we overcome that on questionnaires, is that you answer that question, you ask that question in several different ways so that it can kind of weed out untruthful answers and kind of get to the meat of the data. Another type of way we can collect our data and do our research is through interviews. If we do interviews, we're going to sit down one-on-one with somebody, talk to them, gather data. Usually that's structured to where you have a certain amount of questions, the type of questions you're supposed to be asking. You have, you can code that responses that you receive so that you can gather that data. That is time consuming and expensive to do. And it's hard to get a large number of people to do interviews. Observation. These are naturalistic or structured observation. So observational data is where you would, for example, say I want to go into a kindergarten class and I want to take a look at how many acts of aggression we're seeing in a kindergarten class. So we want to measure, say, how many kids are kicking and hitting and pushing and that sort of thing in a class. So what I would have to do is I would have to go into that class and I would have to sit there and maybe come every day for a while until the kids felt like I wasn't even there anymore. And they go about, when you first have a guest in the class, they're going to act funny because just the act of being observed will change your behavior. Think about it. If you're not doing anything wrong and a cop pulls in behind you, your behavior changes when you're driving. You get a little uptight, you kind of watch what you're doing. Same thing happens when you're observing somebody and they in a research setting. So if I come into that kindergarten class, then pretty soon, once class gets going, I'm going to been there for like a week. Now I'm going to start with my observations. I would have a list and say, I would put a little check mark anytime that, Timmy kicks, if somebody kicks somebody, I'm going to make a hash mark. If somebody pushes somebody, make a hash mark. And I would just keep making marks in all these different columns that have been predetermined that we've already decided on. It can be, and that would be unstructured. Structured would be, say we have designed it so that people are doing a specific task, and it is a structured task where they have to do A, B, C, and D, and we're going to observe them doing A, B, C, and D. So that would be structured versus unstructured. Biological measurements, there's a lot of this. We can use fMRI studies to have somebody think about something, and we can measure what's happening in their brain when they're thinking about something, when they're solving a math problem, something like that. We can look at genetics, we can look at hormone levels. There are several different biological measurements that we can do. A little bit about, this is just an image showing an interview research design. It can provide rich data. However, anytime you're interviewing somebody one-on-one, your interviewee can be influenced by the characteristics of the person conducting an interview. this is something that you have to be very careful of, because when you are asking people questions, you may be giving nonverbal cues with your body language or your facial expression that could lead somebody to answer a specific way. So interview research can be very tricky. You should have very highly trained people doing those interviews. Okay, whenever we conduct our research, we want to make sure that our research is reliable and valid. These are two important concepts. So far in this video, you need to know your scientific method. You need to know about reliability and validity. Reliability is the consistency of measurement across different occasions. For example, if I have a ruler, every time I get my ruler and I measure it against something, it can measure an inch. So if I have a piece of wood, I can put my ruler there and make a mark, and 2 inches is going to be 2 inches every time. So every time I put my ruler against something, it can measure that 2 inches. So that's consistency. The marks on my ruler don't move every time. It stays the same. It is reliable. Validity is the extent to which you are measuring what you're supposed to be measuring. Are you measuring the right thing? So if I take my ruler and I put it in my cup of water so that it can measure the volume of my water. So I just stick my ruler in there. Oh, my volume is 9 inches. That makes no sense, right? That is not a valid measurement of my volume. Okay, it is a consistent measurement because I'm probably going to get the 9 inches every time, but it is not valid. I am not measuring the right thing by using that ruler. If a measurement is unreliable, it cannot be valid. So in other words, if I'm measuring, trying to measure something and it is not reliable, it's measuring something different every time, or my ruler lines were changing every time, that would not be reliable. So if something is not reliable, it also cannot be valid. This is just a table that talks about research methods and limitations. Our questionnaire, large samples, that's awesome. Quick data, awesome, quick data collection. But the preset responses, and it doesn't have depth. So most questionnaires, you're gonna do like a Likert scale on a scale of 1 to 5. How well did we help you today? With 5 being best. So a questionnaire like that, usually, especially a longer one, it just has these limited responses that the person can make. It does not have as much depth. An interview, the advantage is individuality and complexity. However, as mentioned previously, it takes a lot of time and effort of coding. In other words, every time somebody mentions a particular thing, we have a code for that. We have to look at the tapes from the interview, and we have to create a code that can be translated into data. Observations measures actual behavior. Being observed may change behavior. So there's 2 different things on this. So it's not only that being observed may change behavior, like we already talked about and mentioned, there's another factor as well. The differences between the observers. So if say I'm supposed to observe on Tuesdays and Thursdays, and another researcher is supposed to do it on Wednesdays and Mondays, even if we've both been trained to do the research, we have to be very carefully trained so that we are recording the information in a similar way. So different observers may be recording the observation slightly differently. So that's just another thing you have to be very careful about when you do observations. Biological measures, precise data, expensive, relation to behavior may not be clear. We don't always know the relationship between biology and behavior. There are some things that you just can't do in humans. There's some things that you are going to be restricted due to money, due to, I can't go put everybody in the fMRI machine. I can't, do a PET scan on everybody. Some of these things are just really too expensive to do a lot of. All right. when we use experimental research, now I'm going to talk about experimental research and I'm going to talk about correlational research. Experimental research is the type of research you can do to establish a cause and effect relationship. Once again, experiments can help to establish cause and effect relationships. Correlational research that we're going to talk about in a minute does not establish cause and effect relationship. So only experimental design can give you cause and effect relationship. For our experimental design, we have to have an independent variable and a dependent variable. The independent variable is the factor that is controlled and manipulated by the experimenter. The dependent variable is the outcome that is measured to calculate the results of the experiment. For example, one of my experiments, I injected animals with either 0, 2.5, 5, or 10 milligrams per kilogram of amphetamine. That is my independent variable, was the amount of drug they received. So the amount of drug they received was the independent variable. The dependent variable was how fast they ran through the maze and how much they remembered. It was actually a memory test, so how well they remembered the maze, which was measured by how quickly they ran through the maze. So the dependent variable would, in my experiment, was the time it took to run through the maze, which is the outcome that is measured to calculate the results. So for each different group, I measured them all, and then we compare those groups and see if there is a difference in how long it takes to run the maze. So the dependent variable is the time that it takes to run the maze. The independent variable was the drug dose. So we would compare all of those groups to get our results. The advantage is a high degree of control. When you are doing experimental research, you control the environment that you are looking at, or that your research is conducted in. You're going to control everything to the absolute best of your ability to make sure that the only change that is happening in this case would be the change in the independent variable. That is the only thing that we want to see changing, is the independent variable. Everything else should stay the same. The lighting, the temperature, the environment, the researchers, everything you can keep the same should be the same except for your independent variable. There are natural experiments which exist naturally in the world and provide interesting scientific information. There are ethnographic research. Ethnographic research is used by anthropologists. That's when maybe you've heard of people going to live with a very remote tribe or a very remote village somewhere. They become, they live with those people for an extended period of time, see how the society functions, see how they work together. They learn all about that. However, we do have to consider that that is also an observer being in there, and that there might be biases that can leak into that research also. But so anyway, that's a really, ethnographic research is a very important type of research as well. Insights into the whole daily experience. So they're very immersed into the society which they are observing. This is a picture of a very famous anthropologist named Margaret Mead, and she has done a lot of studies about mothers and relationships with mothers and children. And she is in Papua New Guinea, looking at, or talking with a mother and her child from the Manus culture. So she lived here. I don't know how long she lived with these people, but she went down there and lived there for quite a long time to get the trust of the people and really kind of find out how their culture really worked. Because if you're just there for like a week, you're not going to get to know how the culture really works. Okay, research designs. There's different research designs. There's case studies, which are detailed examinations of one person's life. That would be, for example, oh wow, there's so many examples, but basically we're just going to look at one person. A famous one is Phineas Gage. We use him all the time in our intro classes. He's a gentleman that had worked on the railroad, tamped down a explosive into the hole, and it went off, shooting a rod up through his head, causing some frontal lobe damage. So we take a look and see what the damage was in his brain, take a look and see what what behaviors changed. So we can make some assumptions that, gee, we think that if you damage this area of the brain, certain behaviors change, but it is only a case study. It is not generalizable to the general public. In other words, we can say that this happened with this guy. It's possible that maybe this can happen with other people, but we cannot take this case study and generalize it to the rest of the population or say this is going to be the same for everybody. All right, so it is very limited. It's very useful, especially with brain damage and things like that. We can look at these individual cases of brain damage. When a certain area of the brain is damaged, we see certain behaviors and we can make correlations about that. We can get an idea of what may be happening, or that maybe this particular area of the brain is important for certain behaviors. So that's one of the values of case studies. Correlational design, once again, correlation does not indicate cause and effect relationship. Correlational design is only going to show you if there is a relationship between variables. You have to see if there is a relationship. There will either be zero relationship, there will be a positive correlation or positive relationship, or a negative correlation or negative relationship. Now, positive and negative in this sense do not mean good or bad. Negative correlation does not mean that it's a bad thing. Positive correlation does not mean it's a good thing. Positive correlation means that two of your variables will increase or decrease in relation to one another. For example, a positive correlation would be if you study more, your grade goes higher. So that's a positive correlation. Grades go up, study hours go up, grade goes up. Study hours goes up, grades go up. We can say that that is a positive correlation. It is a relationship where both things are moving the same direction. A negative correlation would be temperature and amount of clothing worn. So as the temperature gets hotter, the amount of clothing we wear goes down, okay? When it's 50 degrees, you have this much clothes. When it gets to be 100 degrees, you have as little clothes as possible. So basically, as temperature goes up, amount of clothing goes down. So they're moving different directions. That's a negative correlation. Not good or bad, just negative correlation. Now, these are not cause and effect relationships. They can sound like they're cause and effect sometimes, but they are not. And I'm going to explain why on the next slides. Okay, let's take a look at, hi son, let's take a look at violent video game viewing and aggressive behavior. So on this side, we have viewing violent video games and aggressive behaviors. And what we notice, a lot of research has shown that, wow, we have kids that are viewing a lot of violent video games here. And these kids that are viewing violent video games have a lot of aggressive behavior. So this is a relationship that we're seeing. But can we say that the violent video games are causing the aggressive behavior? No, we can't. How do we know that it's not aggressive behavior? Say somebody has aggression in them or has some underlying aggressive behaviors, and that makes them like the violent video games more. So it could be that the aggressive behavior is causing somebody to watch the violent video games, or the violent video games are causing the aggressive behavior. So it could be either way. So we don't know what direction this relationship is going. We know there's a relationship, but we don't understand what the relationship is. We can't say that, we can say that it's a positive correlation that has been seen in research. Violent video games, viewing goes up, aggression goes up. We can say there's a positive correlation, but we don't know what is causing what. Could there be other reasons why this is occurring? Good for thought. Okay, actually, this is the big reason why correlation is not causation. When you have two factors that are just related to each other, there could be, like I said, violent video game viewing, aggressive behavior. Is it just because the person's more aggressive that they play the games? Or are they playing the games because they're more aggressive? Or are there other factors? Correlational research is not experimentally conducted. So we are just saying that there is a relationship, but we have not conducted experimental research on this. I mean, there have been research, but in our example here, we haven't. Other factors, for example, violence in the home, hyperactivity, mental illness. There could be a lot of other factors contributing to the violent video game viewing and to the aggressive behavior. So it is not a cut and dry cause and effect relationship. If we wanted to weed out a cause and effect relationship, we would have to set up an experiment where we'd have a group watch violent video games, a group watch video games that are very similar but not violent, and then we would have to measure aggressive behavior in both of groups. And that research, of course, has been done as well. And then we could say that something is causing something else. And yes, the research findings, this was done on college campuses with kids that are in a lab setting. And so we can say, yes, okay, the violent video game did seem to cause more aggressive behavior in this group, but it is not generalized out into the world. It is only we can only say that this was caused when in a specific setting, like at this college and in the laboratory setting. Okay. Other research designs, cross-sectional design gathers information from a wide range at a single time period. So a cross-sectional design, these are two types of research that we use in developmental psychology. So cross-sectional would be like, okay, this week I'm going to look at people who are 15 and 20 and 25 and 30 and 45, and just I'm going to look at all these different age ranges at one point in time. So we're going to see on this date, these age groups, this is their scores on this, whatever I'm measuring. That would be cross-sectional. Many ages at a single point in time. Longitudinal study follows the same person or persons over a time period. So I'm going to start off, for example, Flint, Michigan, where they had all the lead contamination in their water. Somebody may want to do a longitudinal study and say, okay, I'm following these kids from the time they were 5 years old in Flint, Michigan, and I'm going to follow them. I'm going to measure them again at 10 years old. I'm going to measure them at 15. I'm going to measure them at 20. I'm going to measure them at 25 and 30 and 35. I'm going to measure these kids all throughout a period of their lifespan, over a period of time, so that I can collect data on these individuals and collect at 2 or more time points. Now, this is really good research. It can give you good data, but you have a lot of dropout in these studies. People move, parents say, I don't want to participate anymore. You know, you have a lot of people that drop out of the study, and it's expensive. You have to track the people. You have to send somebody to do the interviews or to do the, you know, collect the data. It is very expensive to do, but it is research that we do. There's also something called a cohort effect, which I'm going to talk to you about on another slide. So here's an example of studying at the lifespan. A longitudinal study follows the same person over time. So here we have a girl that's in toddlerhood, early childhood, middle childhood, and adolescence. So this would be an example of longitudinal study where she is followed throughout this period of her life and whatever research questions are being asked. All right, more examples of correlation. Physical health and exercise are correlated, but which causes which? Well, we've already kind of done a lot of examples over this. Basically, as exercise per week increases, physical health increases. But are we exercising because we're already a healthy person? And so because we're healthy, we're exercising more? Or are we just exercising more, which makes us more healthy? It could be either way, or there could be a third factor that we are unaware of. Same thing. Okay, so that was an example of the correlation. This is where I'm going to talk about cohort effect. So let's say that I'm doing my study and I'm going to look at religiosity self-reported religiosity, in other words, how religious somebody is over time. And I'm going to look at, in this one point in time here, say, you know, this week we're going to look at it on this such and such a date, and I'm going to look at 20-year-olds and 30-year-olds and 40-year-olds and 50-year-olds and 60-year-olds and 70-year-olds and 80-year-olds. Now, when I look at this data, I can look at this line and I can say, oh, wow, people get more religious as they get older. Okay, that might be true. That might be true, or it might be what we call a cohort effect. For example, somebody that's 80 years old or maybe 90 years old, older people would have lived through a different period of time. Say you have somebody that's 80, 90 years old and they lived through the Depression or the end of the Depression, and they're impacted by that. They're going to have a much different experience than somebody who had a coming of age. Say they came of age in the 60s, and they, you know, your cohort is that group that you go through life with. For example, millennials have a certain group, that's a cohort that goes through time. Our baby boomers are a cohort that moves through time together. They have similar generational experiences, and that generational type of experience can be what we call a cohort effect. So it could be that people become more religious with age, or it could be that these older people were more religious because back in the day, everybody went to church. Okay, just for example, they came from a different cultural era, I guess, and that would be a cohort effect. Okay, ethics are important before you can just go out there and do research on people or animals or anything else. You have to have it all approved through the Institutional Review Board. They're a group that determines if the proposed research follows reasonable ethical guidelines. Guidelines also provided by professional organizations. So you can't just willy-nilly go out and do this stuff. We have to have an ethics committee that approves research. There's a lot of old, interesting research that can demonstrate the reasons why we need these. And hopefully if you take an intro psych class, you can check that out. Or when I get those up on my channel, you can look at that stuff too for the some of the social psychology experiments that have caused some very big ethical dilemmas. Okay, so ethical guidelines, you need to protect from physical and psychological harm. You have to have informed consent prior to participation. So in psychological research, especially, you need to have what's called informed consent. So basically, I might tell you, hey, we're going to do a study on perception, and you're going to sit here and you're going to look at these lines, and then you're going to be asked questions about the lines. Okay, so I sign up. I also have to tell them that they can leave anytime, that they can discontinue research at any time. They can walk out anytime they want, no negative repercussions. After we do and it's confidential, we won't be sharing their information with anybody. The research data won't have their names or anything like that. It'll just be data. Deception and debriefing. So I told you were going to be looking at these lines, but actually it was a social experiment where you were looking at lines, but I had a bunch of, I was asking you which line matched another line, and I actually had a group of people in there saying the wrong answer to see if you were going to change your answer to match those people and say the wrong answer too, or if you were going to say the right answer. So it was actually a social experiment. So I have to tell you that. That's called debriefing. So I have to tell you that. And you were slightly deceived. We try to minimize deception, but then you have now been debriefed because I told you what the experiment really was. So you have to have informed consent and debriefing. All right, the next few slides, there's an appendix here, which will be on your other presentation that you can download. So the PowerPoint will be on Canvas. You can download it. Sorry for the kind of sketchy video tonight. I'm really tired. I just wanted to make sure to get this out to you as soon as possible. I will have your other videos available for you soon. Have a lovely evening. I hope you, I'm going to go ahead and stop our screen share. I hope you guys are doing okay, staying safe, staying healthy, and getting through this crazy online school stuff. So anyway, you guys all take care, and I'll see you soon.